yes, this question's a hypothesis test, and yes, it probably takes a little longer than most questions. I haven't seen a full hypothesis test like this since 2012, if that makes any help. We will look at another one. I just made some copies for some 2015 or 14 questions, last year's test. There's a test on there, but you can skip some steps, like you can skip some conditions and that kind of stuff. So remember how I said that there were 5 FRQs, and then there's the last investigative task is the 6th question? So what question number was this in the test? Number 4, okay? So that's good news, because that means that, you know, you would have at least gotten through 3 before you got to this. My fear is, because they just give you an hour and a half full and just say you have to do all 6 questions in an hour and a half. They don't break it up for you. So you need to give yourself a good 20 to 30 minutes for the investigative task, okay? So you need to monitor your own time. Sometimes people skip around in the questions and start with question 4. They start with the investigative task. They work backwards. You got to find what works for you. I have not seen a full hypothesis test earlier than question 3, okay? But you might want to save this question for the end, because did you see how you ran out of time? And my fear was is that question counts just as much as a quick and easy one would. Like the question we did before on the other side, wasn't that a lot quicker and a lot easier? Okay? So you might want to scan the questions and decide, where am I going to spend my amount of time? You might want to take 2 or 3 minutes at the very, very beginning and kind of look at the FRQs and decide, I'll come back to that one. You know what I mean? Yes?
Are we allowed a reading period like IB?
A reading period.
Like we get to read 5 minutes. Well, you can't touch your pencil.
Oh, no. It's not like that. No, it's just a full hour and a half go. Yeah, that would have been nice, right? Yeah. Because in IB you're allowed to pick some questions to do, and you don't have to do them all, right? Not here. You have to do them all. All the FRQs anyway. Yeah. We'll talk more about the investigative task on Friday. I did print one for us to look at. I don't know if it's going to be ready by Friday, but in the next week or so, we'll look at an investigative task in detail. It's almost like the first 2 questions. The investigative task is like 5 parts. The first 2 are doable. The last 3 are almost not even doable at our level. They're like upper level stat stuff. And it's always stuff you've never seen before. Always. It's stuff I don't know how to do. Okay? My question when I went to the rereading last year, why? What is the purpose of this? It's to disseminate who gets the really high scores and who doesn't. I don't know what to tell you, okay? But it's always stuff that it's always stuff not in the curriculum, but it's stuff you can take the curriculum and apply to it. So my point is that the investigative task says 30 minutes. Save yourself 20. Do for questions A and B. If you have time, come back and look at the last 3 parts. That's my best guess. I graded the investigative task last year when I was in the AP reading, and people still got 5s if they got that question wrong. If you got an I on an incomplete, like, remember it's EP or I, right? If you got an I, you could still get a 5 on the exam. Does that make sense? So my point is that that was just last year. I know it changes from year to year, but don't panic about the investigative task is my point. Yes. Yes. Which is why you can still do well.
Are they shorter than like me? What we've been doing?
No.
For the same size?
These are released questions. These are released questions.
No, the one.
Oh, this investigative. Oh, okay. Yes. I'm sorry. Yes. It would no way in the world would this be an investigative task on the AP exam. That's like, yeah, no. You'll look and see what I'm talking about. All they mean by investigative task is that it's a longer question. That's all. And it's pieces together like 3 different sections. You're going to do, we'll look at it next class. But no way is, no. That's like this is a project. I don't know why they called it an investigative task. It's not the same thing. Okay. Yeah, good point. Okay, so can we look at the rubric? I'm recording this whole thing. Oh, well, whatever. So let's go ahead and look at, remember how I told you where you could go to practice and find some questions? It's at collegeboard.org. We click on AP, and then we click on AP Central. We'll click on course and exams. We'll go to exam information. If it'll, I have to hold it down, right? Right, exam information, and we'll go to statistics. Okay, and here's where you'll find the questions and the release stuff. I think this question that we just looked at was from 2012. Is that right? 2012. So we're looking at 2012, and we'll look at the scoring guidelines for 2012, and it was number 4. So this question was talking about, first of all, before we even look at the question, because I don't even think the question shows up here. What was the kind of test you had to do? First of all, how did you know to do a test? How did you know to do a hypothesis test? It said the word proportion, so you know right away we're dealing with either a 2 proportion or a 1 proportion z-test, right? So we know we're dealing with that. How did I know it was a 2 proportion z-test? 2 different years, right? 2009 and 7, I'm not sure what it was. 8 and 7, okay. So we knew we had to do a 2 proportion z-test, okay? I saw Hunter out with this formed inference and conditions thing to check. Can you have this on the AP exam? No. So you got to memorize those, okay? Bummer. But yes. Okay. Sure. I saw Lindsay looking at her notes. Great for this. Reminding ourselves what to do, what not to do. But obviously you can't have those on the AP exam. Okay? So we want to practice taking these FRQs really with just our knowledge from here on out. Okay? So I am going to ask from here on out that you put everything away except for the formula sheet that's allowed on the exam. Okay? But knowing that this question was a 2 proportion z-test, let's go ahead and look at what the intent of the question was and what how they scored it. Okay? So the primary goal was to set up, perform, and interpret the results of the appropriate hypothesis test, which we knew what it was. State the hypotheses, identify the name of an appropriate statistical test. You had to name it. Hopefully you did. Say the words on your paper somewhere, 2 proportion z-test. Did you? That's going to be part of the grading rubric. Okay? So guess what? If you're running out of time, what can you at least do? Write the name of the test. At least maybe you'll get some credit, right? Who knows? Depends on how they set up the rubric. And then write in a conclusion in the context of the study. We've done that all year long. So let's see how well we did. So we have to list a pair of hypotheses. Okay, step 1. I think it's going to let me scroll down. There we go. All right, now, they did it with their own notation. Could you have done it a different notation? Of course. What are we looking for a null and an alternative hypothesis? They have to be in terms of p, not p hat. So look at that. And you also want to say that your null hypothesis is that the proportions are equal, and that the alternative was that they were not equal. It ended up being a 2-tailed test. How'd you do with that? Anyone get, and who got 2-tailed tests from this? Yay, some of us. Okay, good. It was a 2-tailed test because the wording of the question said, what was the key word in the wording of the question? It was 2-tailed. Change. It didn't say bigger, less than, it just said change, right? 2-tailed test. Good. Okay? Not equal is the same thing. That's what I mean, right? That's right. Good. Now they did 7 and 8 as a notation for year 7, year 8, perfectly fine. As long as you were clear with which one you did, that's fine. If you did P1, P2, and then somehow over on the side said what P1 and P2 were, perfectly okay. I think. We'll look at the grading rubric, but I'm pretty sure that would be okay. All right, step 2. Notice what they say. It says to identify a correct test procedure by name or by formula. So how do you do a formula for a hypothesis test? I'm not real sure. So we'll have to look at what the grading rubric says. I think they really want you to say 2 proportion z-test, but we'll see. With the confidence interval, it's easy to write the formula down. You didn't have to say that, but the formula was clear there. And checks the appropriate conditions. It wants you to do the full test, doesn't it? Okay? So we'll look at the conditions in a second. It says that the first conditions was gathered independent random samples from the 2 populations. We are told that they were randomly selected in the 2 different years. The second condition is large enough, relative, so we had to do the NP is greater than 10 and NQ is greater than 10 for both of the samples. So we have, what do we say, 398, 676, and 333 are all at least 10 of those the numbers that you guys got? Okay. No. This is just, we're going to, no. You can do it the way we've been doing it, it's fine. Now the hypotheses, they might want you to write it in the context, okay? But we'll look at the grading rubric. I would always tend to write my hypotheses both with the letters and the numbers, and then but no, you don't, this is just a sample answer. This is not really the grading rubric yet, okay? Step 3 was the correct mechanics, meaning that the test statistic and p-value were there. You did come, my Jordy. Okay, just put that on my desk. Thank you. So we have the sample proportions. We had to find the p-hats for each of them. We had to pool, remember? Combine your proportions. How many of you remember to do that? Devin, up top. Whoop, whoop. Good job, Monica. Good job. Okay. Remember with proportions, 2 sample proportions, we have to come up with a combined proportion, right? Okay, right? All right, let's keep going. Then we have to find the test statistic, the Z. Honestly, I think that you didn't have to do the work. You could have just given the test statistic the calculator gave you. Which is okay for me, because honestly, I don't know that that's necessary. Okay? They do the formula differently. They did it, it should be this over that plus this over that, which is what we did, how we did it. It's just the 2 proportions subtracted over the standard deviation, right? That's all it is. And then the conclusion and context. So there's 4 steps, okay, to the hypothesis test that they're looking for. They're looking for the hypotheses, the name of the test and the conditions, the test statistics and p-value, and the conclusion and context. Okay? All right. Let's go ahead and look at how each of those is scored. It says each of the steps 1, 2, 3, and 4 are scored with an EP and I, just like they were before. Essential, partial, and incorrect. Step 1, so I want you to grade your work for each step to see how well we do. It's essentially correct if they identify the correct parameters and both hypotheses are labeled and state the correct relationship between the parameters. Okay? What do they mean by identifying the parameters? No, that's step 2. What they mean is if you look at the note here, identifying the parameter symbols in context or simply common parameter notation is sufficient. So basically telling me the correct parameter was P, right, because it's the proportion, population proportion for 2007. Population proportion for 2008. That's all they mean. If you did P1, P2 and told me what those were, you've identified the parameters. That's all they mean by that. Okay? And then the correct hypotheses. Okay? Identify the correct parameters or the but not both. Well, then we have an issue, right? So if you didn't tell me what P07 meant or P1 meant, then that's a problem. That would give you an I. P, partial. How many of you got E's on that one? You told me what the P stood for, and you got the hypotheses correct. Only 3, 4, or 5 of you. Anyone get a P? Partial? That's okay. That would be okay. Right. Be careful. I would, if you're given specific, if you're going to use P1 and P2, be very careful with what P1 equals. Say that next time, okay? Yes. It doesn't matter. It doesn't matter. All right, so some of us got E's, some of us got P's. Did any of us get an I because they forgot to do any of that? It's all right, Kyle. It's all right. All right. It's okay. Let's go ahead. They might be lying. You never know. Okay. Let's look at step 2. So what are we looking for in step 2? That they identify the correct test procedure by name or by formula. I don't know the formula that they're talking about for a hypothesis test. Like there's z-scores and p-values formulas and standard deviation, but there's not a formula for the 2 proportion z-test, right? So they really are looking for that name written down. Checks for randomness and checks for normality. What do they mean by normality? Right, so NP is greater than 10 and Q is greater than 10, right? Okay. So how many of you named it and got the proportions right, or got the conditions right? Okay, up top, Monica, you're doing great. Good. All right, so EE, hopefully, nothing too scary. Let's look at steps 3 and 4. Okay, so 3, essentially, if they correctly calculate both the z-score and the p-value. Notice it doesn't say that you need to show the formula, does it? It doesn't say you need to show, you can just write z equals. If you are running out of time, what are you going to do? Write what the calculator gives you, right? And write it down. No, because you wouldn't know that the grading rubric said that that was step 3, right? So, because they could divide it up any way they want. I taught you 5 steps, if you remember. They were going by 4, because they combined a couple things. So you don't have to number them, no. Okay, and then step 4 is correct decision in context. Did we go over, I feel like we skipped the context. Did we look at the context conclusion? Let's look real quick. Let's take a step back just for a second. I feel like I don't remember reading that. All right, so step 4 says the p-value is real small, okay? Smaller than any common significance. At alpha could be 0.05, which is the most common commonly used, but it could even be 0.01. So you have to say the words, we reject the null hypothesis, and you conclude that there is convincing or statistically significant evidence that the proportion of the adults who would answer yes has changed. There is a difference between the 2. Okay? We don't know which direction, right? Anyone get the correct p-value, by the way? Not that far? Is it because you didn't have enough time? You didn't do a 2-sample one? Or you did a t-test? Oh, yeah. Proportions is these. Okay? All right, so let's look and see whether you got in a 1, 2, 3, or 4 on the exam. It's basically each one is worth 1 point. For every E, you get a point. For every P, you get half a point. Okay? So count up and right at the top of the big circle. Did you get a 1, a 2, a 3, or a 4? Or did you get a 0? If you got a 1.5, please write 1.5. Because if you remember, the AP grader will decide whether you go up to the 2 or down to the 1. And why do we call that scoring holistically? And all that means we will look at your work and decide, do you know really enough information to push you up? Is it clear to me that you kind of know what you're doing to go up? I'm not saying that, Sammy. I'm just saying. Anybody get a 4? Anybody get a 3? Monica? Anyone get a 2? Anybody get a 1? Okay. I think it was a time issue. I don't think it's because you couldn't do the problem. Quite frankly, I think we all could do it. I think it was a time issue. Okay? I did give you 15 minutes, which is more than I probably should have. So we need to practice our pacing. Okay? And we'll work on that. Okay, go ahead and put this away for me if you would. We are going to spend the rest of today talking about a 2-sample t-test. I'm going to turn the lights up here so Hunter doesn't get sleepy on me. Stretch, stand, do some yoga. I'm good? Yes, love. Charles brings up a good point, and it's a point that we should all listen to. He said, sometimes they don't make you do a whole hypothesis test. I would say often they don't make you do a whole hypothesis test. I've only seen a full one a handful of times. I just wanted to show you that they do exist, and not so long ago, 3 years ago. But sometimes like part of the hypothesis test will be included in in another question. So it'll be like a 3-part question, A, B, C, D, or 1, 2, 3, 4, or however they want to name it. And they'll say as part 3, you know, the p-value for this particular situation was 0.3 or 0.03. Write a conclusion and context. And that would be like just a portion of the whole thing. Does that make sense? So sometimes they will just take and give you like little pieces to do, but this was one where it was from beginning to end. All right. So let's do some comparisons here with 1-sample-T methods and 2-sample-T methods, okay? Before spring break, we really kind of finished up the 1-sample, and we started talking about 2-sample-T methods. What is the 2-sample-T method that we did? The matched pairs. Good. So matched pairs is something that is considered 2 samples, but I'm going to write it underneath the 1-sample. Even though there are 2 sets of data, for example, there are verbal scores and math scores, like your SAT investigative task, 2 sets of numbers, but they're still going to be considered 1-sample data. Why?
Because they're using the difference.
Right. So when you have something that is matched pairs, you're going to combine them or subtract them, I should say, and find the difference between them, and then you have 1 set of data that you're dealing with that from now on. Okay? So that's why I'm going to put it in the 1-sample-T procedures. Yes.
Is that like where you have to find the T-interval?
The T-interval you can use in either case. The T-interval is just the confidence interval based around it. Okay? But let's go ahead and make sure that we have the difference in sets of formulas and things. And you should find those on the kind of the stapled handout sheet that I gave you. It's not going to be as clearly defined on the formula sheet, but we should have both of these items in front of us so we can compare and look and find what we need to do. Okay? So with 1-sample-T methods, what is the test statistic? Is it a Z or is it a T? All right. So we know we have a test statistic. What's the formula? Okay. So the sample mean minus the population mean divided by the standard error. And what is the standard error or standard deviation? The sample standard deviation divided by the square root of n. Okay? Good. That's how we'd find the test statistic. Good. What other formulas do we need? Okay. I'm not sure if that's there. Oh, yeah, by the way. Okay. Good. Is that the same thing? Yes, yeah, sort of the same formula. We have a, well, I'm not going to write anything else, only because the standard deviation is just simply this, isn't it? Right? And that's part of the test statistics, so we're good. All right, when we get to, we should do the confidence interval just so we're okay. So the confidence interval is going to be the sample, so x bar, sorry, not t bar, x bar plus or minus T star. What do I have to be careful with? The degree of freedom, right? Okay. And then so that's the sample test statistic. And the standard deviation is just this. Would you agree? All right. That's 1-sample methods. And if we're dealing with matched pairs, we'd just be dealing with the differences of all of those. We're using our difference data to come up with that information. When we get to 2-sample methods, we have some different formulas to use. And I'm going to be looking at the formulas on the formula sheet that you're allowed to use. And if you look at the right over here, you'll see where it says sample mean, sample proportion. Do you see that over to the right? So that is your standard deviations for 1-sample data. And then right underneath it is 2 samples. We've already done the proportion stuff at the bottom, right? Now we're dealing with the sample means. Now there's 2 formulas there, okay? Let's write the one formula. So we have the the test statistic, which we'll just, let's start with the standard deviation, okay? That's going to be this. Oops. The standard deviation of 1 squared over the size of that sample plus the standard deviation of 2 squared, or the second set of data, over that size of sample. Kind of looks like the proportions one a little bit, don't you think? Except for we're squaring the standard deviation rather than multiplying p times q. All right. If you look underneath your formula sheet, it says there's a special case. And what do they mean when standard deviation 1 equals standard deviation 2? Well, first of all, if we knew the real standard deviation, would we be doing the t-test anyway? What would we be doing? If we knew the population standard deviation, what would we be doing? A z-test anyway, okay? So it doesn't have to be, it doesn't necessarily deal with that. It's talking about if the standard deviations were the same, then we could use this other formula. That so rarely ever happens. Ever? Ever? So we're just going to kind of ignore that for now. Yes?
Is standard error the same thing as standard deviation?
Standard deviation, no, it's not the same. Standard error uses the sample standard deviation, and we often use that because we don't know what the real population mean is. And I know that that's the note, so this could be considered an S, right? And that would be, then that would just become a standard error in that case, okay? We use the standard error always when we're talking about confidence intervals. If we're not given one in the hypothesis test, then we would use the sample. Okay? I'm trying to use the same notation as what's on the formula sheets all. Okay? All right, if I wanted to find a test statistic, and now I'm jumping to this sheet because it's not really on your formula sheet, so let's kind of decide what the test statistic's going to look like. I'm assuming it has it on here. It does, okay. At the very bottom where it says 2 means, independent means, do you see that at the bottom down there? That's where we are, and that's what we're talking about. So the test statistic's going to look like this, okay? Is just going to be, rather than the sample minus the population, it's just the difference of the 2 samples on the top. And again, does he think it's going to matter what order we subtract them? It doesn't matter as long as you're consistent every time and you're clear with which way you subtracted. So they said 1 minus 2, which is fine. Okay, and then the denominator is just going to be your standard deviation, right? And they use S here, Sammy, rather than the sigma to denote that it's a standard error. So if you want to, just treat these as S's as well. Because if we're using a t-test anyway, it really should be a standard error. Yes. Okay? How are we doing? Okay so far. A lot of you IB bio people looking familiar? A little bit? Eh? Okay. Okay. It's just the difference between, the observational difference between the means and the square root of the standard deviations over the sample size. Okay. So let's go ahead and, by the way, the confidence interval is also listed on here, right? Do you see that formula? So it's also on your formula sheet, not the one you can use, but it's just your test statistic minus the t-star times the standard error. Same kind of thing. So let's look at an example. Oh, we shouldn't. We have to do one more thing. Conditions, of course. So the conditions are listed here in a nice nutshell, which I think is nice. So read those conditions over on this stapled paper. A little bit better than the way the book describes it, I think, quite frankly. Number 1, what do you think? Always. Random. Now, because we're talking about 2 samples, what do you think we're going to have to reference? Both samples have to be randomly selected. So let's talk in context of your SAT investigative task for number 4, shall we? I'm going to help you through this. Number 4, to start that, you're going to be doing, because in question 4, we know we're doing 2 different independent samples. They are independent because they are not matched. Okay? It's a difference between males versus females. Was it the math scores they were having you look at? Okay. So we're looking at the difference between the males and the females. They're independent. Okay? Boys versus girls. Who's smarter? Who's better? Who does better in math? 2 independent samples, right? So that's why we're here. What would the first condition be in that particular, how would you address that random condition? What would you say on your investigative task? Okay, that would not be enough. How many samples do you have? No. How many samples did you take? No, the sample size was 30. How many samples did you take? Okay, well, kind of 2, right? And that's the problem. Well, you took 1. You took 1 sample of 30. But here's the problem. Do they differentiate in your investigative task as to whether they're male or female? Somewhere, and if you look at your table, right, when you did your sample, one of the columns was gender, right? So what are you going to have to do? Well, you don't have to get 30 females and 30 males. But what you do have to have is enough males and females. Why did you pick 30? Okay, so you're looking on to the conditions 1 and or to the second and third condition. So we're going to come back to that. But you're right, because didn't we have to pick 30 for a reason initially, earlier on? We picked 30 for a reason, because it had to be big enough to meet that the fairly normal condition, right? Because it has to be bigger than 15, or if it was in between 15 and 30, we had to check some stuff. But if it was bigger than 30, it didn't matter, right? So we're probably going to have to collect some more data to answer question 14, or question 4. But let's come back to that. How am I going to address the randomness? Well, we just made a decision that we have to divide our sample that we collected into 2 groups now, don't we? Okay? We have to take our 30 that we have highlighted in our chart, and we're going to say, okay, all the males are over here and all the females are over here. We're going to have to divide them up. Okay? If you do yours, the number of females that Lena gets might be different than the number of females Maddie gets. Is that okay? Yeah. But what you have to be careful is that they are, like Kyle suggested, big enough. Okay? You have enough of them. Is it possible that in your 30 you only got 2 females? It's possible. Not likely, but it's possible, right? So you're going to have to make the decision for yourself if you're going to need to collect more data. Well, yeah, they don't have to be the same. They don't have to be the same size. Okay, 16, 14 is fine. But the problem, if you keep your 16 to 14, is now if you look at the, hang on, where is it? The conditions here. If you look at number 3 in the third condition where it talks about the shape of the size, and is it the nearly normal condition? If we are in that 15 to 30 range, what's the problem? We have to check, we've got to graph it and see if it's skew or not. Okay, so if you want to do that, you're fine. You don't have to collect any more data. Okay, if you don't want to have to worry about that, then you want to get at least 30 and at least 30 of each. Okay, you don't have to have the same number, but at least 30 females and at least 30 males, because each individual sample has to meet those conditions. Yes?
So when we put it into the random integer function on here, do we just keep going until we get at least 30?
Mm-hmm.
We could end up having 50.
50 females and then 30 males. Is that what you're saying? I know what I think you kind of did, and I think I know what you're saying. I want you to keep selecting until, so you say in your randomization procedure for this question, if you're going to end up selecting more people, you need to address that in your write-up. I am going to select more people randomly from the table because my individual samples of males versus females is not enough, okay? And so by saying that, you're telling me what you're doing. Now, I would say I'm going to start by picking, I need 5 more males. I don't know, whatever. And so I'm going to just keep hitting my random integer function until I get 5 more males. I'm not going to worry about if a female shows up. I'm going to ignore the females. Does that answer your question? Okay, good. Clear. Second thing that you have to do, if you are getting more people and you're making your sample bigger now, I want you to use a different color highlighter, okay? Or circle them or underline them or something to denote that you selected them in addition to. Because weren't the first 3 all the ones you've already highlighted, right? So now we're on part 4. And part 4, if you are going to end up selecting more, not required, by the way, if you want to check the individual normalcy for each of those and it works out great, that's fine. But if you don't want to have to worry about it, then just select more people. Yes? That would work. Not 7-leaf wouldn't show up on a calculator. It might be quicker to do a box and whisker or something to show skewness. Okay. Any other questions about the conditions? Yes? If it's between 15 and 30, you have to show me some kind of graph. Normal probability plot would work. Is that normal probability plot linear? But tell me what kind of display you're using. If you're using a normal probability plot, then say so. If you're using a histogram, then say so. And say, you know, based on this box and whisker plot, it really looks to me like there's a heavily skewed right. So I know I'm going to need to sample more. Yes? It does, the samples, they don't have to be the same.
No, but I'm not saying that you need enough of each gender.
He's saying that, like,
Yes.
part under 15. Like,
Yes, if you don't have at least 50, oh, that's true, you only did 30, right? If you didn't get 15 and 15, you would have to.
Yeah.
Yes, yes, I'm sorry, yes. But you might only have to select like 1 more male. You know what I'm saying?
Yeah.
You would have to select a lot more, is my point. And up until 15, and then after 30, you don't even have to check anything. Is that better? I feel like I'm confusing you. Devin. Then you would be fine as long as you check the normalcy of each. Okay? Make sure in your write-up you're clear about that you did that to begin with. Okay? All right. Have I addressed all the conditions questions? No, yes, no. You have to have at least 30 of each if you're not checking the normalcy. Yes.
And if we are checking the normality, we have to have at least 15.
Yes. Yeah, anything under 15 you can't deal with. Good? Unless you're told the data was normal to begin with, which we're not. Are we? I don't think we are. Because wouldn't that be crazy if we were? True. So if you want to say that and then you say they did you hear what Devin said?
Devin, I'm citing Devin.
Devin's kind of right. SAT scores are normally distributed, aren't they? They're standardized to begin with. So we're told the data is normal, so do we even have to check the normalcy condition? Kind of no. As long as you state that, he's right. You just state it in your conditions. When you're checking that condition, you can say, because it's an SAT score and they are standardized, we don't have to it's met the condition. And he's right. It has already met the condition that way. Good point. Saving us some time. That's great.
Nice.
For time's sake, I want to move on. I think it's okay to do either. Okay. What I will say is that it's not normal by males and normal by females. Okay. So that's the iffy part. All right. Can we move on now? Now, the reason I just spent 10 minutes on that is because they are not normal in and of independent samples. They're not. Standardized scores are for everybody. The entire thing is standardized. So they're not going to care if you're female or male. They're not going to take the female sample and normalize them and take the male sample and normalize them, right? So because of that, they're not independently normal. So you have to kind of be careful. I think for the purposes of this task, I will accept it by saying you've addressed the condition, and that's okay with me. All right? All right, let's move on. After conditions, by the way, independent of each other is important with that 10% condition. That's in addition to the 10% condition that normal t-tests have. They have to be collected independently. Are yours going to be collected independently? What does that mean? Why did I underline that? Think about your investigative task. Yeah, so the males aren't going to affect the females in any way, right? So they are independent of each other. In other words, they're not matched. That's all that means. They're not matched. Okay. Let's try a different example other than your SAT so you can kind of model yourself along with it. Will that be okay? Okay, so keep your investigative task in the back of your mind, and let's talk about what we would need to do. Obviously, you're going to need to state your conditions, and I should have that somewhere listed. Did I write that somewhere, what the conditions should look like? Hang on. No, great. All right, so what would the conditions look like? They are written on here. If you look, the conditions are listed here on your formula sheet for a 2-sample, what the conditions, or what the hypotheses, should look like. I'm going to skip the confidence interval for a minute because I want you to do a test and we'll come back to that. So let's actually talk about this one. And we're not going to do a confidence interval, we're going to do a hypothesis test.
We're doing the two independent meanings.
Yes. Okay. Does talking elevate blood pressure? I actually had some people do this as their end-of-year project, but they didn't do talking. They did, does exercise elevate your blood pressure? And kind of we already know that, but that's okay. So does talking elevate it? So the following data for the diastolic blood pressure were collected to answer this question. These were the people talking. This was the data I collected from them, and the counting from them. Okay? So let's think about, this is the data that I have. Think about this as being your males versus your females. We have the data. Now what? Okay? The confidence interval will be fairly quick, so let's just do it, and then we'll do the full hypothesis test as well. How would I construct a 95% confidence interval for the difference in blood pressure? Are they independent samples, first of all? Are they matched in any way? I don't know if they're matched, do I? Okay, I don't. It would be a good question to match, quite frankly, don't you think? Okay. Where you could have like the before and the after, right? But it doesn't say that they are. So we're going to treat them as two independent samples. Yes, baby.
Counting the numbers.
Good question. I don't know. Should it be the other way around though? Well, no, we'll leave it this way. It's fine. All right. Good question. This one really is matched, isn't it? Isn't this a matched pairs t-test? Because it's before and after. So I don't think this is a good example to do for this particular question. Okay? Do you see why I'm skipping it? Because it is matched. What's your blood pressure before you talk? What's your blood pressure after you talk? It's matched by person. Not independent. Not independent. Not independent. Come on. Give me an independent one. This one will be independent. All right, let's look at this one. This one I'm not giving you the raw data. Okay? So think about your SAT score, SAT project. How am I going to get my raw data, my 2 samples, my males versus females, where I'm going to get the mean, standard deviation, and sample size? How am I going to do that? 1 var stats. You put one of them in each, right? 1 var. You can actually do 2 var stats if you want. Put your data in list 1 and your data in list 2. Do 2 var stats, and they'll work right at once. Okay? But you're going to need your mean, standard deviation, and sample size for each of your 2 independent samples. Do you agree? So that's one step you will need to do on your own. Can you please label that clearly in your investigative task so I can find it? The mean and the standard deviation and the sample size of each of your independent samples. We good? Hunter? We're good? What did I just say? You don't even know because you're sleeping. Label clearly your two independent samples, means and standard deviations. Okay? All right, so let's do a confidence interval. We're trying to figure out the cost of groceries in an inner city grocery store versus a suburban grocery store, and we're trying to decide, is there a difference between the two? Okay? So what we want to figure out is the difference in the cost of groceries. So a 90% confidence interval. We're going to assume the conditions, okay? So we're not going to check them here. We're going to assume that populations are independent and approximately normal. So we've kind of assumed the conditions are ready for us, but you will need to check those conditions yourself or address them yourself in your investigative task, okay? So how would I do a 90% confidence interval? What would I do? I'll write the formula in case you forgot. Do you agree? Okay. Now what? Now what? Okay, subtract the means. So 3652, which one should we go? Which direction do you want to go? The suburban being sample 1, inner city being sample 2? Doesn't really matter as long as we're labeling it, right? I don't care. All right, so let's do 3652 minus 3940, and we get negative 288. Perfect. Plus or minus? Now what? What is the degree of freedom? What was the degree of freedom with one sample data? Sample size minus 1. What do you think it's going to be if I have 2? Well, it can get complicated. Okay?
1 minus 2.
No, it's not actually. It's the largest 1 minus 1 is what we're going to use. The largest sample minus 1. So in this case, it would be 44. That's an estimate at best for degree of freedom with 2 sample sizes that are different. Okay? Estimate at best. The calculator will actually give us a very precise degree of freedom and is a lot more exact. Okay? So you probably want to use that value. We'll get there. But we'll go ahead and just put our T-star with a degree of freedom of 44 for right now. So whatever the calculator gives us will be a little bit different because it's going to use a different, like some convoluted formula that they get for the degree of freedom, quite frankly. Okay?
So would you want us to use just the raw data?
Well, because we don't have the raw data,
I mean, but for the investigation.
you can use this. This is okay. Ask me what? Great question. All right, so let's look at this. I'm going to actually write it on here. Okay? When we had 2 sample methods for proportions, we had to pool, didn't we? Guess what I'm going to tell you for means?
Yay.
Okay? So with means, we're never going to pool. Okay? There's a whole, we're running out of time. Good grief, this went by fast today. There's a whole description in your book in chapter 25 about pooling and whether you pool for sample means and when you should and when you shouldn't. It has to do with whether or not the standard deviations are known or not and blah, 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 blah. Just don't do it. It's so rare that you need to. We're just not going to do it. Okay? Period. Check. Move on. Got it? That easy. Good question, though. Thank you. I forgot to address it. All right. Where were we? Here. All right. But proportions we do, right? Proportions we do. All right, so here we are. Now we have to do standard deviation. So we have what goes in here. 1.1 squared over 45 plus 1.23 squared over 35. You with me? I'm okay at this point. You've kind of shown me what you want to do. Let's just go ahead and write down our answer. I'm cool. So how would I do this on the calculator? Stat, test, it's an interval, right? So we're looking at an interval, so 2 sample T interval. And it says data versus stats. In this particular example, I didn't have the raw data, But on you, you will, right? Won't you have it when you collected your sample? So you could use the data, but we're going to use the stats right now. And I'm just going to plug in the mean. 36.52. My standard deviation was 1.1, and my sample size was 45. 39.4 was the second mean, 1.23, and my second sample size was 35. My confident, they wanted to do a 90, didn't they? 90, pool, no. Calculate. So to me, it looks like this is going to be negative 3.321 to negative 2.439. Is this enough? Is this evidence statistically significant or not? Why not, Sean? Therefore, it is statistically significant. If it captures 0, we don't know anything, right? There is no difference. But because it doesn't capture 0, we have something, right? So it is statistically significant. So we have evidence here. I don't think that's even a word, but I'm going to say it. To say what? What can I say? Look at the context. Not even a difference. We know who has to spend more, and we know by how much. That's what a confidence interval suggests, doesn't it? Who spends more? The inner city or the suburban, and why? Inner city spends more. Why? Because it's negative. We subtracted that one, and my confidence interval is all negative. Therefore, right, it's bigger. Does that make sense? So we know the inner city will spend between $2.44 and $3.32 more than the suburban. Oh, we are 90% confident that right? Sorry, baby. Yes? I'm listening. I know. I'm just doing this one just because. Give me 1 second and I'll answer your question. I'm going to say suburbanites because I wanted to. Okay? Yes?
So, does that mean for question 2 when you're talking about the confidence interval?
That was a 1 sample confidence interval. Number 2. Because there was only one, it was only the math scores.
Yeah, but I was asking, would I say, like, instead of the average, the school's average scores are between blank and blank, would I say is better than the state's average?
Yes, that's exactly what you would say. Yes, because that's what you're comparing it to. Perfect. Question?
So on the investigative test, you want us to do a confidence interval and a hypothesis test?
For number 4, one or the other.
One or the other.
This gives us evidence too. I said one or the other for number 4. Won't a confidence interval also give us evidence to suggest one thing is the males score higher than females or vice versa?
95%.
I would do a 95. Does it say percentage, by the way?
No, it doesn't say.
Okay. So it just says nationally males tend to have a higher math score than females. Is that true at this high school too? Well, if I did a confidence interval, a 2-sample T interval, wouldn't I be able to answer that question with 95% confidence? So I think that's fair enough to do for number 4. And since we're running out of time, we probably don't want to rush the hypothesis test portion. Should we just say do a confidence interval? Will that be okay for number 4? I'm cool with that. But you got to check your conditions. Fair enough? One or the other really would be enough, would answer the question. But if you want to do both, I'm going to grade both. So if you get one wrong, it's going to count against you. Okay, so I wouldn't suggest that. So I'm fair with number 4 being a confidence interval, but just check your conditions. Yes.
If we were to do a hypothesis.
Yes.
Since it says that nationally one does better than the other, what would be our HO?
That they're the same. Yeah, they're the same. And that was where I was going to go next. If I was going to in this, what would the null and alternative hypotheses always be? Really, is that mean 1 equals mean 2, or then one is greater or less than the other, or not equal to, is the alternative. But the equals is always going to be your. Sometimes they say this. Right? Or less than 0 or whatever. Okay? Either of those are okay, but that will always be for a 2-sample. I think it even says that here. Yeah, if you look at this, it tells you here that that's what the null should be. Do you see that? Hunter.
And then, would you want us to keep it in fraction or round to the nearest whole since it's going by points on the SAT score?
For the interval?
Yes.
Your confidence interval should never be rounded. So 3 decimal places is a good idea.
So 40, should I say like 48.1?
You should would. You sure would. I am for a little bit, yes. All right, so if you would kindly, we have about 10 more minutes. I'm going to stop the recording for now. Your homework is to finish your investigative task. It's really just number 4, not a whole lot. We will do a 2-sample T test in full on Friday in addition to doing another FRQ. Okay? Fair enough. Fair enough.